So if you're given a set of ordered pairs as your function, then to find the inverse function, all you have to do is switch x and y for each ordered pair, okay? But what about if you're actually given a formula? Like, for example, take a look at example 4. If you have the function f of x is equal to 2x minus 4, how do you come up with the inverse function, okay? Well, there are some steps, okay, written down. So under find the inverse of a function defined by an equation, okay, this is what you're going to do if you are given a function, given its formula, and asked to find the inverse function, okay? So in step 1, you're going to replace f of x with y. Okay, we learned that long ago that f of x and y are the same thing. So you're going to replace f of x with y, and then you're going to do the biggie, okay? The heart of inverse functions is switching x and y, okay? So now that you have now that you physically have a y present, you can switch x and y. And then in step 3, we're going to solve for y. And then once you do that, that's your inverse function. Okay, your last step will be to replace y with the f inverse of x notation. Okay, all right. So these are the steps you need to follow. We're going to do practice, practice, practice. Okay, so one more time. You're going to start by replacing f of x with y. Then you're going to switch x and y. You're going to solve for y. And then you're going to replace the y with f inverse of x. Okay, so let's take a look at example 4. Okay, it says find a formula for f inverse and give the domain and range of both f and f inverse. Then sketch both functions on the same coordinate axes. All right, so let me show you how this particular example is laid out. We are given the original function, that's f of x is equal to 2x minus 4. At the bottom, you see a place to write down the domain and range of f, and then the domain and range of f inverse. And there's also a grid here because we're going to graph both f and f inverse once we have it on the same grid. Okay. All right, this is how I'm going to do this. I am going to start by concentrating on the original function and what I know about it. Okay, once I write down everything for the original function, then I will go into f inverse. Okay, all right, so let's look at this. We have f of x is equal to 2x minus 4. Okay, so that's the same thing as y equals 2x minus 4. Okay, again, I'm just dealing with the original function. It has the format y equals mx plus b. Okay, I'm going to go ahead and graph it. Okay, and then later, once I find the inverse function, I'll come back and graph that. Okay, so I'm going to start by graphing this guy. This is a line. It has y equals mx plus b form. Okay, so here the slope is the number in front of x. So this has slope 2. And the y-intercept, the b value, is -4. Okay, so the first thing I'm going to do to graph this function out is I'm going to graph the y-intercept. So the y-intercept is -4, and then I need to keep applying the slope. The slope is 2 over 1. That's rise over run. So I'm going to go up 2, right 1, up 2, right 1, and so on. Okay, now I'm going to actually keep doing this. I'm going to kind of fill out the grid, and you'll see why later. I'm going to just keep doing this, up 2, right 1. Okay, so give me a second to kind of fill this out, and then I'll draw the line through the points. And then I'm also going to go in this direction from the y-intercept. I'm going to go down 2, left 1, down 2, left 1, down 2, left 1. So here is the original function's graph. Okay, so I'm going to go ahead and connect these dots with a line. And remember, the line keeps going in both directions forever and ever. All right, so here we go. All right, here's our line. Okay, original function. I'm going to label it. This is f. Okay. All right. I also can go ahead and write down the domain and range of this function, of the original function here. You know, you can, as far as domain goes, you can either get it from the formula or you can get it from the graph. Either way you go, you should get the same thing. Y equals mx plus b. It's a polynomial, so the domain is going to be all real numbers. Okay. Range we have to get from the picture. Okay, so basically find the lowest point on the line. Okay, well, the line keeps going down, 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 down forever. So the lowest point is going to be negative infinity. Okay, and then in the other direction, the line keeps going up, 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 up forever. So the highest y value is going to be positive infinity. Okay, so the domain and range of this particular line is all real numbers. Okay, so we've done everything for the original function. Okay, so I just wanted to get that out of the way before we started dealing with the inverse function. Okay, the inverse function, I'm going to go ahead and put it in a different color. I'll put its stuff in red so you can go back and tell. Okay, so we don't have the inverse function yet, so we need to go and form it. Okay, so we're going to follow the steps that were just outlined. Okay, so I'm actually going to draw a line here to kind of separate my work. Okay, so let's do this. All right, so here we go. I'm going to go back to the original function here. Okay, the step said the first thing you need to do is you need to replace f of x with y. Okay, so I'm going to go ahead and write down y equals 2x minus 4. And then you need to switch the x and y. Okay, so I'm going to come to the statement, and instead of y, I'm going to put x. So I'm going to get x equals 2y minus 4. Okay, so I switched x and y. Okay, so now it says solve this for y. Okay, so we need to solve it for y because as we left off, it's solved for x and we need to solve it for y. Okay, so we get y by itself. All right, so I'm going to start by adding 4 to both sides. Okay, that's going to tell me that x plus 4 is equal to 2y. And so now if we want to get y by itself, y is multiplied by 2. So we just need to divide everything by 2. Okay, so that is going to be your inverse function. Okay, on the right side, the 2's will cancel. So you're going to get y equals x plus 4 over 2. Okay, if you want, you can go ahead a step further to kind of simplify this. You can break this down, this fraction down. So we can do x divided by 2, okay, plus 4 divided by 2. Remember, the correct way to break up a fraction is to take every piece in the top and divide it by the entire denominator. The reason that I'm doing this, it's going to help us graph, okay? So a little bit more here. So I'm going to get y equals, if you're dividing x by 2, that's the same thing as multiplying it by 1/2. So x divided by 2 is the same thing as 1/2 times x. And then plus 4 divided by 2 is 2. Okay, so we're almost there. We've solved this for y because we have y equals, and then we don't have any y's on the right side. And then the last step said to replace y with f inverse of x. Okay, so the inverse function is going to be f inverse of x is equal to 1/2 times x plus 2. Okay, this is the inverse function right here. Okay, so I'm going to box it. Okay, all right. Let me quickly tell you why. You could have stopped right here. You could have said f inverse of x is equal to x plus 4 over 2. That is perfectly fine. That is correct. The reason I broke the fraction down is because we are asked to graph the inverse function on the same grid. And to me, x plus 4 divided by 2, that's pretty hard to graph by hand. But if I break up the fraction, now I've got f inverse of x is equal to 1/2 times x plus 2. That's in the format y equals mx plus b. Okay, and so I know it's a line. Okay, so let me write that out to the side. This is y equals mx plus b. Okay, when I graph this out, the slope is going to be 1/2, the number in front of x, and the y-intercept is going to be positive 2. Okay, that's why I took the few additional steps to break the fraction down so that I could recognize this as a line and it's going to be easy to graph. Okay, all right, so here's the inverse function. We've got the formula for it. Okay, so now what I'm going to do is I'm going to graph it out. Okay, I'm going to graph a line. I'm going to put the y-intercept first. It's going to be at y equals 2. That's the b value. And then I need to apply a slope of 1/2. So my rise is 1, my run is 2. So I'm going to move from the y-intercept. I'm going to go up 1, right 2, up 1, right 2, up 1, right 2, and I'm going to keep doing this. I'm going to fill out the grid just like I did for the other line, the blue line, okay? If I come back to the intercept, I'm going to reverse my directions. I'm going to go down 1, left 2, down 1, left 2, and so on. So give me a second to get these dots on here, okay? So now I'm going to go ahead and connect them with a line that extends indefinitely in both directions. Okay, so here we go. And then I'm going to notate this. Okay, this is the inverse function. This is f inverse. Okay. All right. Why are you being asked to show these two graphs on the same grid? Well, if you go back to page 2, one of the characteristics of a function and its inverse is given in number 4. If you graph them together on the same grid, then they are mirror images of each other about the line y equals x. Okay, so I'm going to come back to the grid and I'm going to plot the line y equals x. I'm going to put it in black. Okay, so let me go ahead and draw it in. It was actually one of those basic functions that you learned in section, I think it was 3.4. Okay, so here we go. Okay, this is the line y equals x in black. Okay, remember the input is the same as the output. So y equals x is the line that goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on, as well as in the other direction, -1, -1, -2, -2, and so on. Okay, so what you're seeing here, okay, if you the black line is y equals x. If you fold the sheet of paper along that black line, then the blue line and the red line will lie on top of each other. They are symmetric about this line y equals x. That is a characteristic of any function and its inverse. If you graph them on the same grid, they will be symmetric about the line y equals x. Okay, something else you should notice. Okay, I'm going to call out a couple of points on the blue line. Okay, so the blue line was my original function. So I see 2, 0 right here. Okay, so remember, if you switch x and y, you should see that point on the inverse function. So 0, 2 should be on the inverse function, and it's right here. Okay, and you can check this out. This is going to happen for all the points. Okay, I'm not going to check everything, but I'll check a couple of things. Let's go up here to this point where my cursor is. This is 6, 8. Okay, right here. So if I switch x and y, 8, 6 should be on the inverse. Okay, there it is, right here. Okay, I'll do one more to check it out. Let's look at this point right here. This is -1, -6. Okay, so if I switch x and y, I should see -6, -1 on the graph of the inverse, and here it is. Okay, so everything should be jiving. Okay, all this stuff should agree. Okay. All right, last thing we need to do, we need to determine the domain and range of f inverse, okay? Clearly, if you look at the red graph, the domain is going to be all real numbers. The leftmost point is -infinity. The rightmost point is +infinity. Remember, you have a formula for f inverse. It has the format y equals mx plus b. That's a polynomial, okay? The domain is going to be all real numbers. Okay, if you look at the range, you have to get that from the graph. We're looking at the red line, the inverse. Okay, the lowest point on the graph, the line goes down, 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 down forever. Okay, slowly, but it goes down, down, down forever. So the lowest y value is going to be -infinity, and then the high point, the graph, the line climbs forever. So the highest y value is going to be +infinity. So domain and range are also the domain and range of f inverses, they're both all real numbers. Okay, so another thing to observe here from this example, okay, one of the characteristics of a function and its inverse is the fact that what I wrote down here, the domain of f is always going to be the same as the range of f inverse, and the range of f is always going to be the same as the domain of f inverse, and you see that illustrated here. Okay, the domain of f is the same as the range of f inverse. Okay, they're both all real numbers, and the range of f is the same as the domain of f inverse here. Okay, so with these types of examples, okay, where you have to find your inverse function, you have to give the domain and range of both the of the original function and the inverse function, and you have to graph f and f inverse on the same grid, you see a lot of the characteristics between a function and its inverse. You see that come to life. Okay, let's go ahead and try another one.